I gotta use the bathroom. It's not too bad yet, but I'm gonna try to finish this video before I have to use the bathroom really bad. Hey everybody, we're gonna play around with collision, and specifically I'm gonna play around with what's called axis aligned bounding boxes. You can look that up, you can Google it, but really all it means is we're going to be looking at rectangles that are not rotated or translated. Well, they're translated, but they're not rotated on the X or Y axis, and therefore X and Y they're just along the axis, so there's no rotations involved. So they're just plain old rectangles. So we're going to start there and see what we get. First, though, we need to take a look at the sprite. What I want to do is, if we're going to have this bounding box that we're going to test against for collisions, then we need to create one of these things. Now, we did flirt with this a little bit, and there was the text field. You can see I looked at this earlier, with this get wrecked in the text field that gets its rectangular area. So we'll utilize that, and instead of get wrecked, we'll probably just have wrecked, and I want to put that on the sprite. So I'm going to copy and paste that, and then we'll modify that as needed. So we'll get rid of the text or the text field, make it sprite, and in this case I want to do some special things, because if you remember our sprite class, this what should we say, the XY of the, let's see, where, make a little note here, where X and Y indicates, or is, let's just say is, it's easier, the center of the sprite. If you remember that, we put that X and Y location is in the center of the sprite. So that means what we want to do is we'll have to, well, I'll show you what I'm going to do. What we want to do first, I want to make this a local. So we're just going to basically make a table with all these values in it. We'll return it as a rectangle, but this is going to be offset, and it's going to have to be offset by the height. But I don't want to calculate that twice. So what I'm going to do is first we'll come in here and say, well, the width is going to be self.w times this scale. See that? So if we scale the thing, we want that rectangle to scale along with it. Makes sense, doesn't it? Yes, it does. So now we have this with the width and the height correctly scaled, and then in order to create the X and Y, we can simply do the following. We can just say that equals the self.position.x minus r.width, and we want to do half that width. And that's just easier than, I mean, I could put it all in one line and just return it. It's just writing this over again and then dividing it by 2. I don't know. You can do it if you want to. Put it all in one table and just return it. But I'm doing it like this because I like it better. I don't know. I may change my mind later. But anyway, that's how we're doing it right now. So you'll see what we're doing. We're just saying the X and the Y, we're going to pull them back up to the upper right-hand corner. So let's say translate X, Y to the upper right corner of the rectangle. We'll spell it out. Look at that. And instead of get wrecked, let's just say wrecked. So now, if this is correct, we should be able to come down here and say, let's test it by going and getting this rect. So we could say self : rect. And then we'll just do a love.graphics.rectangle. And this one will be a line. And all we have to do is the starting position will be the upper left-hand corner, which is rect.x and r.y. The width is r.w, and the height is r.h. I'm going to run that, and we'll see what happens and what kind of errors we get. We may not get any. Oh, that's one thing. That's right. Let's go into the main.lua, and let's uncomment the switch to test scene, because that's what we're going to be working with. We want the picture of the guy, and there is our little rectangle. And it moves with us, as you see. Fantastic. And you may say, what's the deal with the spaces and stuff like that? Well, that's how big we specified that sprite to be, a 16 by 16, and then we've scaled it. So that's correct. We'll probably want to make some sort of collision rectangle that we can control that size with and resize it later on. But we're just kind of getting into the basics right now. So that's good. And my urge to go to the bathroom is increasing, but we're still safe. We're still safe. I'm not experiencing any type of extreme urge yet, and extremely uncomfortable. We're good. We're okay. So let's keep going. Fantastic. All right. It's fantastic. Test we can get rid of. We're going to want to put something in utils, and we can get rid of main.lua. Let's create an alter ego by taking this player, and let's paste that. So we just copied the player file, and I'm going to call that enemy now. And as such, we're going to have an enemy here, and I'm going to make this an E. And I better go down here and return an E. And then we want to do a search and replace, and we want to find P colon, and we want to replace it with E colon. So E colon. What's the plural of colon? Colons or coli? If it was coli, it would be E. coli. Wouldn't that be funny? No, it's not funny. Okay, so now we have really the same thing as what we had before. I just want to get rid of the control stuff, so we can just do that. We'll come in here and probably modify this later, so I'm going to leave that code in there. And then additionally, what I want to do is actually not here. We want to do that with the player. I think this will suffice, and then let's go into the test scene and let's instantiate. Oh, and by the way, I was looking at this also, and you see we've passed a string into this constructor for player, and there is no string. We're not taking a string. Really, what we were going to do was take like an animation state, I guess you could call it. So we could say that, and then we could say animation state equals animation state or idle. That way we can pass. So that makes sense, right? So now, before that wasn't doing anything. Now that's actually doing something. So anyway, not that it matters actually, because I'm going to take it back out because we have a state machine here, and we're actually changing the state based off of all that. So let's undo all that. So we don't need any of that stuff. So I'll just remove that. Just an additional aside. Okay. Let's do the same thing here, but let's make ourselves an enemy. So we're going to have to come in here and grab enemy from our newly created class. And then we can do this, and we'll make a self.e for enemy. These aren't the droids you're looking for. Move along. So here we go with enemy. And we also need to set the position of our enemy. And that's going to be on the sprite. Position.x, and let's set it to 320. And let's see if, yeah, okay. Let's also tint our enemy to be a different color. That's self.e.sprite.tint. I think it's tint color equals, and that'll be just a table. Unless we come in here and do, matter of fact, let's do that. We're going to need this anyway. Let's include the utils. So we'll do lib utils, and then we can just say, where did we go? Here. We'll say u.color. Let's make him red. Like that. So he's a different color, so he's indicated, and obviously I missed the, where is it? Yeah, it's all one word. Of course it's all one word. Okay. Check it. Check it. There's our enemy. And right now we can run into him and everything. And remember, since we added him second on our list and we don't have a layer on him, we do go behind him because he is in front of us at this point in time, but we can change that later. That's not important or germane to what we are speaking about now. Next thing we would like to do is add the actual collision detection. So with that in mind, what we want to do is add something to the utils class. We already have point in rect, we have mouse in rect, and now what we need to do is detect. We want to detect whether two rectangles are colliding. And that was, remember what I said, axis aligned, basically bounding box collision. So that's what we'll call it, and we'll say we want rect 1 and rect 2. We will now then perform some interesting arithmetic. So what we want to do basically is, let me show you. We want to say, we want to check and make sure, we want to see if what we need is, I'm getting ahead of myself, aren't I? We want to calculate the right side of rect 1. So that's a local, so I'm saying rect 1, the first rectangle, we want to see the right side of it. So we're looking at the right side of it, the x part. And that's going to be rect1.x plus rect1.width. You see what I'm saying there? Yes? That's going to be the right x value, you see? Okay? So, and then let's go to, we want to also calculate for our y calculations, we want to calculate the bottom of that first rectangle. That's going to be rect1.y plus rect1.height. So you understand, because our x and y are at the upper left of the rectangle. So we want to get all 4 points so that we can utilize those in a comparison. You see? So with that, we must grab rectangle 2's. See if I can do this fancy thing. Rectangle 2 is going to be done the same way. So we also need its, oops, I'm pushing the wrong button. Oh, so funny. So we have rectangle 2 here. Once again, pushing the wrong button. How about that? Rectangle 2. That's what happens when you never did learn how to touch type. Okay, so these are our other 2 coordinates. So these are the right coordinate and then the lower coordinate. So we can now look and check. We want to return when the rectangle 1's right. Okay, follow me here. When the right side of the first rectangle is greater than or equal to the second rectangle's x position, and rectangle 2's right is greater than or equal to rectangle 1's x position. So we're saying, is the right side of the first rectangle greater than the left side of the second? And is the right side of the second greater than the left side of the first? If it is, then they are inside of each other, at least on the x-axis. You see? And we're going to just do the same thing for the y-axis. So I'm going to copy this mess of garbage here. It's not garbage, it's code, it's logic. Logic is not garbage, correct? And I'm going to change these r's to bottom. So, and then y. So we're going to look and see if rectangle 1's bottom is greater than or equal to rectangle 2's upper left. And then rectangle 2's bottom is greater than or equal to rectangle 1's y. And that will return true if these axis-aligned bounding boxes are indeed colliding. Now, what we can then now do is come into the test, if you will, and we'll go into update and we'll go and check those things. So we can say if u colon, and then I've forgotten my name of my little function here. That's this little fellow here. And now we need a self.player. And remember, this is on the sprite, which we could pull out into the player itself, so you wouldn't have to go through all of this ... stuff. But this is the way we're doing it right now. And that's going to be a colon. Now we want to get the rectangle of that little guy. And the other rectangle is the self.enemy dot Sprite, and we'll get the rect of him. So if they are colliding, and we're going to go ahead and pre-populate this. So if they're colliding, I want to set the player's sprites, I think it was tint, there it is, tint color, to u.color. We'll say no red, and let's say 128 green, 128 blue, and let's do like a 200. All right. Otherwise, if it's not colliding, then let's just set him to a white tint color, which is the original player color. Now, I'm going to run it. Prepare for errors. Yes, that's what I thought. Okay, so let's go back. Utils Lua 27 here. Rect1 dot x and rect1 dot width. Attempt to perform arithmetic on field x, which is a nil value. Well, you know, I don't believe our error is here. I believe more that our error is probably somewhere else. So let's go look once again at our test. Well, we should be doing this correctly. Sprite rect, and that looks correct to me. So what we should do next is go here and look at our rectangle here, and that looks also correct. Yeah, we did note that this is indeed correct. And our error once again is what? In function attempt to perform arithmetic on field x. Back to utils. And which one was it? Lua 20, utils Lua 27 right here. Rect1 dot x. Yes, that's what you get, ladies and gentlemen. We have an enemy, and we have self.e as self.p. Those should be valid rectangles. I'm not sure what we're missing. Let's see, rect1, rect2. I'm sure it's obvious to you at home. Oh, here. Forgive me once again. That is not a colon. We don't want an implicit self. That's what was going on. So instead it was passing 3 parameters. The first one was self, which was this, and it didn't have an x. So we want the dot only. Let's run this again and see if it works. And yes, so now, if we have it all correct, we should be able to walk over here, and as soon as we hit this, we turn this color. So, and let's go all the way over here, and when we get all the way over here, yep, that is looking fabulous, ladies and gentlemen. That just looks fabulous. That's wonderful. I'll tell you right now. Okay, but we needed to test the Y portion, you know? So let's do a little hack here. Not something that I normally endorse. I'm kidding, of course. I do it all the time. Let's add an additional if key here in the update of the player. If key is key up, up. Then let's do basically the same thing we're doing here. But instead of velocity x, it's just going to be just a -1, and then we're going to do that to the y position. And then else if key down, which is the down arrow. That's the down arrow. Then we're going to just make that a plus. So we want to be able to test all of those parts of the rectangle just to make sure that they work right. So if I go down, I go up. So that's all working. And you can see I can, oh, you see that? Look, so we can test this corner up here. And you can tell that's all working just nicely. And I can just tease around that edge like that. As soon as I get over here, boom. So we're looking good as far as our collisions are concerned. We're getting correct. So we have, in my professional opinion, we have validated this axis aligned bounding box collision detection function. We've added a few things. Where to next? Perhaps to do, perhaps circle to circle. Oops, crickle to circle. Circle to circle collision. And that will be easy. We can say function u dot, I don't know, what do we call it? Circle collide. And then we could say circle 1, circle 2, and that's going to be easy, people. And I tell you, and it's not function. That's going to be easy. What we'll have to do is we'll assume, and we're not going to test this today. I'm really getting ahead of myself, actually. And my need to pee is really, it's still under control, so we're still going here. Circle 1 dot. Actually, what we want to do is we want to hold on just a moment. I'm going to pull up paint.net here, which I already pulled up. And we'll just do a little drawing. So we'll have two circles. It's a phenomenal circle. It's a phenomenal circle. Where's my anti-aliased? Never mind. That's probably on the brush, isn't it? Yes, there. Anti-aliased. Much better. Circle 1. It has a center. X, comma, Y. We have a circle 2, and that has a center X1, Y1, say. And what we want to do is calculate the distance here, D. So D, if, I hope you like my drawing, if D is less than, and we'll call this circle C1, and we'll call this circle C2. So therefore the radius of C1 is R1, the radius of circle 2 is R2. So if the distance between these 2 points is less than R1 plus R2, then they're colliding. Then, boom. Gotcha? Okay, so that's what we want to do. So we need to calculate the distance between these two, and that is done using Pythagorean's theorem, which is the distance local D equals circle 1 circle 1 dot x minus circle. We're not going to test. By the way, we're not testing this in this video. We'll test it next time, okay? And I'm just making sure you understand that. What we want to do here is, really what I want, and I did this in the twins, as you see here, I want to do power here. So I want to bring this over to the Utils library, and let's just add this here, because I want to make power here. So we want power of this. I want to square that, and we also want to add power of circle 2 dot circle 1 dot y minus circle 2 dot y, and we want to square that. And let's see, what is the Lua has a surely it has a square root. Is it SQRT? Most of the time it is. Lua user manual, luausers.org. Look, math.square root returns the square root if that's what I want. So let's do this, and let's do sqrt, and we'll do math sqrt. And let's see. So what we want to do is take the square root of this. So we're getting the, and you remember what Pythagorean's theorem is. It's a squared plus b squared equals c squared, which is what we're doing. We're solving for c. So you're looking at the difference between the x values plus the difference between the y values. You square them, and then you take the square root, and then you have the distance. And then we just simply return d is less than circle 1 dot radius plus circle 2 dot radius, and that should do it. Well, that should do it. So we don't have to say to do. We'll say we'll say for next time. Here's what we will do: circle collision, refine this. Yes, okay. I think that's all we'll do today. Let's go ahead and run it. Make sure I didn't screw something up strange. Okay, nope. So everything's good. Cling, cling. Okay, good. Okay, until next time, I'm going to go to the bathroom now, and I'm hoping that this was a very good episode. I'll see you next time.